Hello everyone, my name is Nicholas from Exolvate Games team and welcome to part 2 of making Spatial Inventory System in C++ for Unreal Engine 5. Today we are in part 2 of making this system, and basically we are reconstructing it. This system is previously made by Raid's channel in Blueprints, and today I'm reconstructing it with you in C++, and I'm just going to explain some things. So in the previous part we have made some blueprint widgets that we attached to our screen. Basically we have made toggle inventory logic, we have made inventory grid widget, and we have made inventory widget along with other files or basically classes that we have made, but I'm just going to mention about these two. We have made this inventory grid widget that we have attached to our inventory widget, and in today's part we are going to make a look for our inventory grid widget that is attached to our inventory widget. So yeah, we are going to draw some lines. We are going to make it look more like spatial inventory and not like empty empty object. So yeah, let's begin the work. So the first thing that we are going to do is to attach our inventory component to our grid inventory character, basically third-person character blueprint in the editor. So let's do that right now. The first thing that we need to do about that is to declare a variable that will hold a reference to our inventory component. So let's do that right now. Type inventory component, and I need to mention that in your situation it can be named differently. So if you name differently this inventory component, or basically your actor component that you're going to attach and that is representing the inventory component, just type u and then the name of your class that is representing that inventory component. So yeah, in my situation it will be u inventory component, and I will name it inventory component. Okay, did I spell it well? Yes, I did. And you will see this red line right here. We need to import that class. So here below this we can just type class and then just copy and paste it. So the red line has disappeared, I believe. Yeah, it is. And go to your .cpp file. Now we need to import our inventory component, or basically to include it. In order, we need to be able to change some of the reference that are... Hello, this is Nicholas from the future, and I mistalked about including our inventory component. And why we are including it. Basically my mouth is working faster than my brain. So we are including it because we want to do something with that reference, and we basically just want to attach it to our character. If we just import it by typing class and then the name of our inventory component class, we wouldn't be able to do that. So yeah, have that in mind. Okay, for now that's it. Let me see in my other project what we need to do. So the thing that we need to do is to basically now attach our inventory component to our character, basically to our third-person character. So type inventory component, or basically this variable right here that we declared previously. So this inventory component that is holding the class reference of our inventory component class. So just type inventory component equals create default subobject, and we need to get a class of our inventory component, and that will be this class right here, your inventory component, and we need to paste it in between those two signs, less and greater. And now I think, let me see what we need. I think that the first thing that we need is a name to our inventory component, and that will be just inventory component. And the second thing that we need, okay, we don't need it, just a name and a semicolon on the end. And the thing that we need to do is to give a specifier to our declaration. We need to give it a specifier of edit anywhere, and I'm going to explain it in a moment. So okay, your property edit anywhere, just type like this. So basically in the inventory component we are going to declare some variables that will be number of columns, number of rows, and tile size. Maybe there will be something else, but I just cannot remember now. But you get the point, and we need to be able in the editor to change those values when we select our inventory component in the third-person character. So yeah, that's the reason why we are using this, why we are giving a specifier to our declaration of inventory component. So let's declare that variables that we need to in the inventory component. So go to your inventory component.header file, and we're just going to delete these comments, and we are going to delete this public because we have already a public. Just going to copy this and paste it below this constructor. Okay, this is good now, and let me delete those spaces. Okay, and here below the public we need to declare those three variables that we need. So that will be a columns, rows, and the tile size. So let's declare the first. That will be an integer 32, or basically we can use maybe 16, but never mind, I will use int 32. The first one will be columns, the second one will be rows, and the third one will be actually a float, and that will be tile size. And we need to give a specifiers because we need to be able to change those values in the inventory component. So you guessed, we need edit anywhere specifier. So just type your property, edit anywhere, and we need to give it a category. So just type category equals. I'm just going to name it IC, or basically the inventory component, and I'm going to type IC info, and I'm going to type inventory columns. So basically this sign right here is representing that will be that this right here will be a subcategory of this IC info category. So let's do that for rows and the tile size too, but we're going to edit this. We don't need columns but for rows, and here we need a tile size. Okay, now let's just go to inventory component.cpp, and here in the begin play let's just type a simple print string. So you're going to do that by typing g-engine and then minus greater sign, add on-screen debug message, and just type -1. The length will be 5 seconds. The color will be maybe green, and the text will be, let's say, success. So basically we are printing a simple string because I want to check if our inventory component is attached successfully. And my editor is not opened, but if your editor is opened, you just can click a button in the right down corner. So yeah, just click to compile your code. I'm just going to do that in the code editor by clicking Ctrl Shift V. And let's see if there's any errors. Cool, there is not. I'm going to launch my code, actually my Unreal Engine by clicking Ctrl+F. Ctrl F5 actually. Okay, so let's first check if our component is attached to our third-person character, and open full blueprint editor. Let's see in the on the left side here in the components panel, and yeah, our inventory component is attached. And if you take a look on the right side in the details panel, you will see this IC info, and then this inventory columns, inventory rows, and inventory tile size. We can basically change values of those variables. So yeah, we are going here to declare how much columns, how much rows, and what the tile size will be in our spatial inventory system. That's the cool thing, and let's just begin simulation and check if our print string is shown, and it is. So in the top left corner it will show success, and that will represent that our inventory component is attached successfully. So cool. Now go to your code editor, and now the first thing that we can do is to close some of the files that we are not going to use anymore. So that will be this inventory component, inventory data structs. Okay, we're not going to close this. These two, close this item info and item widget 2. And do we need this? I think not anymore, so don't worry about these red lines. It's just IntelliSense, and basically if I build my code again, it will just show success, so don't worry about that. So just close this, and now here, let me just check. Okay, so just close this too. And here in the inventory grid widget header, we are going to declare some of the variables that we are going to use. So let's do that right now. Let me see my other project. What are those? And the first thing, let's adjust this public, convert to protected. And we are going to specify those variables under the protected. So the first one will be integer, and that will be columns. Yeah, we already declared columns in our inventory component, but we are going to bind these columns that we declared here in the inventory grid widget to the values, or basically to the variable that is declared in the inventory component. You will see later. If you don't understand now what I mean, you will see later what it is. So the second one is integer also, and the last, or basically the next one will be float, and that will be, yeah, you guessed, tile size. The next thing that we need will be 4 arrays. So the first one will be array of a type float, and that will be start x, or basic start x. And I'm going to explain it in a moment. We need 4 of those, but the second one will be start y. The third one will be end x, and the next one will be, yeah, you guessed, end y. The next one will be, let me see. Okay, the next one we need to get a reference of our structure that we have made in inventory data structs. So let me just open that file to show you where it is. Inventory data structs.h. Okay, so we need a reference of this structure right here in order to get these 2 arrays. So just copy this, paste it, not actually that, but just type f lines, and we need this asterisk right here, and I'm going to name line struct data, so semicolon on the end. And let me see if we need to import it. We don't need to. This is good. And those red lines are a little bit boring, but okay, never mind. And the next thing that we need to do is to basically declare the native paint override function. That is a function that will help us to draw lines and make our empty object look like actually a spatial inventory, or basically a grid inventory. But before that, we are going to declare 2 functions. So let's just type a functions comment, And the first one will be override function. That will be actually a native construct. Native construct override, and this override function will be triggered when our inventory grid widget is constructed. The next one function will be a function for creating line segments, or basically the function that we are going to use in order to create coordinates for our lines that are going to be drawn in our grid inventory. And the next one will be actually a native paint override function that I have mentioned. So just type virtual int 32 and then native paint. Okay, and for this native paint function, we need some of the parameters that if we want to declare this override function. So let me just override, and let's declare it to be const. So in order for this function to work, we need to specify those parameters. You will see that error type native paint. Okay, so I will just copy and paste those parameters, but pause in your situation, just pause the video and retype those parameters. I'm not going to explain what each parameter do, because we are not going to use them. They are less important now, but I'll say that if we want for this function override function to work, we need to specify those parameters. So yeah, have that in mind. We cannot declare this override function without those parameters. And this IntelliSense is a little bit boring. Let me just restart my code editor. Okay, so we are back, and you will see that red lines has disappeared. And finally, okay, the next thing that we need to do is to actually, first we need to create definition for this native construct function. So right click on it, quick actions and refactorings, create definition of native construct in .cpp file. The next thing that we need to do is to create definitions for these two functions too. So just right click on it, quick actions and refactorings, and then create definition. And there is a native paint function. So just quick actions and refactorings, create definition. And there will be these parameters. So cool. Now we can just start to implement the logic that we need. But before implementing the logic, we need to do another last thing, and that will be to type actually not begin play, but native construct. So just type super and then native construct construct actually, because these two native construct and native paint are override functions. So we need to do that for native paint too. So just type native paint, okay, and we need to just copy and paste these parameters, okay. So just like this, okay. Let me just copy and paste them. So layer ID. The next one is in widget style. Okay, and the last one is, let me see, be parent enabled. Okay, I think that's it. The red line has disappeared, and that's a great sign. So let me just see in my other project. So the first thing that we are going to do is here from the inventory grid widget, we are going to cast and get the reference of our grid inventory character, and throughout that cast, or basically reference, we are going to get the reference of our inventory component. So yeah, we're going to do that right now. We're going to type a grid inventory character, and did I spell it A? grid inventory character. Yes, I did. So this asterisk right here, and then I'm going to name it character reference. Okay, but before that we need to include our class because we are going to do that. We are going to do something with that reference, and it will be just a grid but without a, and dot age. Okay, so the red line disappeared. Now we need to initialize this character reference, so just copy and paste it. Character reference equals cast, because we are casting now, and we need this less greater sign in between them. We need to specify a class that we are casting to, and the last thing that we need is a reference to our character, and that will be get owning player pawn. So it returns the owning player pawn that's owned by player controller assigned to this widget. So yeah, by that we're going to get the reference of our character. We're going to get the reference of our grid inventory character, or basically third-person character in the editor. And now, throughout this reference, we need to get the inventory component reference. So we're going to specify a variable. So type of u inventory component. We need this asterisk, and we're going to name it inventory component. Now we need to basically just initialize that value. So just inventory component equals. Now copy and paste this character reference, and because this is a pointer, we need to type this minus greater sign and search for inventory component. Okay, but there's no an inventory component. That's probably because our inventory component is under protected, and let me see if it really is. So go to your .header file of your character, and yeah, it is. So just delete it from protected and paste it below the public. By that we're going to get we're going to be able actually to get the reference of our inventory component. And here it is. So basically just semicolons, and now we are getting our reference of our inventory component throughout this character reference. The next thing that we are going to do is to basically check if our character reference is valid or not, and I'm going to use something that is called a guard clause, and basically I'm not going to explain you what it is. I'm just going to show you what it is otherwise. So if it's valid, you're just going to get something like this, and you're going to type your code here, and that's basically the same as a guard clause, but let me just delete those. But if it's not valid, it's gonna return our code, and everything that is below this return is not going to basically run. So yeah, that's the thing about guard clause. Okay, so let me see my other project now. As I said previously, I'm going to explain why we are making, or basically declaring these variables. And I said that we are going to bind these variables right here that are in inventory grid widget to the values that we are going to specify in the inventory component in the editor. So yeah, we are going just to type columns. Just to get some space. Columns, so minus greater sign, or actually equals, not minus greater, because that's not a pointer. And we now need a reference of our inventory component, because in the editor we are going to basically type those values in our inventory component, and we need to store those values into columns variables that we specified here. So some kind of that's basically communication between them, and now we need to get columns, and basically we're not getting because they are probably under protected. So let's go to inventory component dot header, and they are not actually. They are not actually, but let me check again. Maybe did something wrong. Not there, but there columns equals. So a value of a type u cannot be assigned to an entity of type. Okay, so let's just columns. But okay, yeah, I know what's the problem. We need to basically include that class right here because we are doing something with that reference. So just type include, and then we need inventory component dot header, and the red line will disappear. So we are going to do that for rows and for tile size too. Just here we are going to initialize rows, and we are going to get the value of a rows and tile size here too. Okay, so we specified that. The next thing that we are going to do is to get basically height and the width that we want from our in our grid inventory based on how much columns, how much rows do we have, or basically do we want, and how big our tile size is. So first we are going to make a new variable. So declare it. It will be just a float, and the first will be new width, and it will be just columns times tile size. Okay, and we need same thing for new height. New height equals rows times tile size. Okay, the next thing that we need to initialize is this line struct data too. We need to initialize all the variables that we have specified here, except these ones. Okay, so let me just we're going to move this line struct data a little bit up, and we're going to copy this, and we are going to paste it here in the .cpp file. We are going to type line struct data equals new f lines. Okay. The next thing that we need to specify are, or basically to initialize, not specify, are those four arrays. So let's get this start x. Basically, start x when we are initializing it, it will be an empty array. We're going to do that for start y. So just type start y equals empty array. We are going to do that for end x equals empty array, and yeah, you guessed, we are going to do that for end y. So basically that will be an empty array. The next thing that we are going to do basically is to initialize or basically create a new variable here in the native construct. And let me see my other project. That will be okay. And now the thing that we need to do is this grid border right here. We need to slot it as a canvas slot in order to change its width and height, because later we are going to use a set size. Not later, but in a moment, we are going to use the set size function to change the size of our grid border. So just go to your .cpp file, and we need to specify uCanvas panel slot. We need to specify a variable that will be of a type uCanvas panel slot. And we are going to name it border as canvas slot, because as I said, we are going to slot this grid border as a canvas slot, and we are going to type equals u widget layout library, and we don't have that library included here. So we are going to include it in order to use functions that are stored in that library. So here below this includes, we are going to do another include, and it will be in folder blueprint actually, slash widget layout library, and the red line will disappear, and now you widget layout library. Okay, and we need to get a function that is called, let me see, slot as canvas slot. Basically, about this library, there is Unreal Engine 5 documentation on the internet, so you can search it and see all other functions that it has. Okay, now let's get to the point. So slot as canvas slot, and we need to type grid border, but because as I'm saying again, we need this grid border to slot as canvas slot in order to change its size. The next thing that we need to do is to now get this border as canvas slot reference, and then paste it. We need to get a function that is called set size, and we need to specify inside an f vector value. So yeah, as you see, you'll see that it needs f vector. So just type f vector, and I'm going to hard code it. You can just specify maybe a separate variable that will be something like a new size, or I don't know what you want. That will be a type of f vector. Okay, and the first thing that we need to specify in the that f vector to the variable will be width, and the second one is height. So I think that now we can test it out to see if our grid border, or basically the size of our grid border, is changing. So let's and I close my editor again. So I will first build it to see if there's any error here in the editor. You can do that. You can do that in the editor by compiling your code in the bottom right corner on the compile button, so there's not any error. I'm going to launch it by clicking Ctrl F5, and let's see. Okay. Let's wait a little bit, and let's go to our third-person character. Let's go to our, basically let's just click on Open Full Blueprint Editor. Let's click on our inventory component. And here, let's say we want 5 columns, we want 10 rows, and the tile size will be 50. Let's compile it, let's save it, and then let's begin simulation and click our input action button. So yeah, you will see that our grid that basically our grid inventory has changed its size. Let's test out with some other values. So let's go to our third-person character. We'll set it to 10. We will set the columns of 10, and it needs to be a square. So let's just begin the simulation. And yeah, as you see, our grid border, or basically grid inventory or spatial inventory changed its size. So yeah, that's the cool thing. The next step that we need to do is to draw some lines, because as I said many times, we need to make it look like spatial inventory, or basically grid inventory, and we are going to do that with create line segments that we specified, and other thing that we declared previously you will see in a moment. So go to your code editor. Okay, now we need to implement a logic for our create line segments function. The first thing that we are going to do is call it here in the native structs. Okay, let me just, in order to fill those arrays that we previously specified it, as empty arrays. Okay, the first thing that we are going to do is do a for loop. So let me just explain what we are doing now. We are creating coordinates for our lines, and we are going to make a coordinates for where we are starting for our x lines, when coordinates for starting y lines, and basically the same for end x and end y's. So basically we are going to fill those 4 arrays with coordinates, and later we are going to use that coordinates to draw lines and make our spatial inventory look like a spatial inventory. Yeah. So the first thing that we need in a for loop is int 32, because we need to get this I, and it's some kind of standard for index in the for loops. The next thing that we need to check if it's wait, let me just type and let me just I++. So basically we need to check if columns are greater or equals to I, and then on the end we need to type I++. And now we need to specify a variable here, like this is something like a local variable in the blueprints. So just type float x and then type equals index times tile size. And let me just show you something different that we are going to use from now on. Delete this x and just type those brackets. This is something that is called brackets initialization, and sometimes it is better to use, and sometimes it is better to use just equals, or basically standard initialization. But you can Google it on the web to see when it's good and when it's better to use this bracket initialization. The next thing that we are going to do is to get this line straight data, and then we need x lines structure, or basically array that we specified in our inventory data structs. Let me show you in the file to remind you again. So let me find it. Okay, inventory data structs, and we basically made this structure right here, and in that structure we made these 2 arrays. Okay, so now let's go back to our inventory grid widget.cpp. We're going to get that x lines structure, and we are going to use a function for adding the elements to our array. We are going to add an f vector to d, and that will be an x and a x. Okay, and the next thing that we need to do is to get the array of y lines and not x, and we need to add we need to add f vector. Hey guys, Nicholas from the future again, and about this part of calculating our coordinates that we are going to use for drawing lines, I want to add that you don't need to worry about whether you understand this at first glance or not. This actually represents a slightly more complex mathematical calculation, and even if you don't understand it, it's not at the end. Try to understand at first how this fits into the arrays that we made previously. So yeah, peace out. And we are adding f vector because we have specified, let me go just again, we have specified that our array is type of f vector 2D, and every element that is in this or this array needs to be of a type of f vector 2D. So yeah, you get the point. Now we need to type 0.0f, and we need to type columns times tile size. And I have one thing, not columns but rows, and we are going to do that okay, we are going to do that again, but now we are going to check if rows are greater or equals to our index, and we are going to specify the y variable, and we are going to basically we are going to specify the tile size times I, and here we need to change from X to Y, and here we're just going to change it. Oops, not microphone, sorry. We are going to just type columns X, basically times style size. Okay. And basically, this is some sort or some kind of calculations that in order to get the coordinates for our lines. And let me show what those calculations are. So let's just do another for loop. And now we are going to do for each loop. So you're going to do it by typing const f vector, and let's say that will be elements, and we are going to store all the elements that we are going to specify. Wait, let me just type, and I will show you in a moment. So we need this array right here, and in this elements we are going to store all the elements that we added to our X lines array, and this is this right here, and this right here. So we're just going to print string, so gengine, and then add on-screen debug message. The first one is -1, the next one is actually the length of our print string, that will be 5 seconds. The next one is color, and we are going to set it to red, and the next thing is to basically print those elements. So we are going to do that by getting the fstring library, then getting the printf function, and we need to type text, and then we need this %sign, and then dot to f. Okay, but we need 2 because we are getting the f vector 2d, and in f vector 2d there are 2 float values. So just something like this, and I'm going to type start x and x, and here we need to type elements dot x and elements dot y. Okay, so semicolon on the end, and we are going to do that too for y lines array. Like I said, I want to show you what are those coordinates that we are going to use to draw our lines in our grid inventory, but we are just going to change it here from start y to start y and end y, and let me save it. And I think that there's nothing else that we're going to do here in the current line segments. Let me just launch, let me just first build my code to see if there's any errors, and there is not. Let me launch my Unreal Engine, and let me show you by printing print strings what those coordinates are. So when I basically click my I button, or basically input action button for toggling my inventory, you will see in the top left corner the coordinates that we're going to use. And yeah, you see, so there are start y and y coordinates, start x and x coordinates, and yeah. Okay, so now we are going to do the last thing for this part, because I think that we are doing this long enough, and this part is long enough. Everything else we are going to do in the next part. So the next thing is to basically draw lines in our grid inventory. Okay, so first here in these two for each loops, we are going to basically just delete these print strings, and here we need to get our start x array, and then we need to add, and the element that we are going to add each time when we loop our x lines is going to be basically elements, because we store it here in the elements, elements.x, and as I said, this .x will represent the first value of this f vector 2d, because as you know, f vector 2D has two values. And now we need, because this is an x lines array, we need to do that also for and x array. We need to add elements there. And that will be just elements dot y. We are going to do that also for y lines on each element in the y lines array in our structure. So we're just going to copy and paste it like this. But we need to store start y and end y coordinates. Okay, and as you know, these start x and x, start y and end y are arrays that are of a type of a float, and yeah, basically we're just going to store the float value of coordinates, so we will know that the start of x and the start of y, and you basically just get the point. So the next thing that we need to do is here in the native paint override function, and this will be basically the last thing for this part. We now need to draw the lines for our grid inventory or spatial inventory. So let me just take a look on my other project, and the first thing that we are going to declare is a context, paint context that we will need in order to draw our lines, and you can just copy these parameters that we specified here, except this first parameter. So just copy and paste it, and we are going to override these parameters, and that's the way you can just declare the paint context that you're going to always use here in the native paint override function. The next thing that we are going to declare will be a custom color of our lines in the our grid inventory. So it will be type of f linear color, and I will name it just custom color. Rates used some kind of gray color with 0.5 opacity, and I'm just going to use that too. So for R 0.5, for G also 0.5, and for B 0.5 F, and for opacity we need also 0.5 F. And the next thing that we need to declare, but actually I'm just going to declare it later, because I want to show you what will be without that we are going to declare and basically do later. For now it's a mystery. So for now I'm suggesting you to just retype the code I'm going to type, and when I finish my typing, I'm going to explain the whole code block that I'm going to type. So just like this: integer k equals 0. Now we need a for loop. It will be int 32. We need to specify I. The first it will start to loop from 0, and then we need to check if let me just get this line struct, this x line array that is stored in line struct data. So we need for each time check if the size basically of our x lines array in our line struct data is bigger than our index, is greater actually. So this is the way you can get the size, or basically how much elements do you have in your array. So basically just typing .num, and we need to just type I++, because each time we want it to add by 1. The next thing is to just write another for loop, and it will be j int 32 j equals the first index is 0. Then we need to check if we can just copy and paste it. So the same thing, but for now for our y lines array, and we need j plus plus. Okay. So now just type k equals y, and like I said, I'm going to explain it in a moment what the whole code block that we will write is doing. And the next thing is to basically get our drawLine function that we are going to use for basically drawing our lines. But first we need to import or include a library where that drawLine function is. That will be in the blueprint, and then widget blueprint library. So this right here. This library will store the function that we need, and the other function that you can check on the Unreal Engine 5 documentation on the internet. Just search for this widget blueprint library. Okay, and now we need to type widget blueprint library, and then we need a function that is called drawLine. So the first parameter that we need is paint context that we declared previously. The next one will be a start position of our line. So let's just type like this. This is again hard-coded. You can declare a separate variable and then set it like this, but I'm just going to do like this. And we need our start x array, and we will just going to get every time when we are basically looping, we want the I index of this start x array. You get the point. I will explain it a little bit better later. Now just type start y of a k, so the k index of this. The next one is position B, or basically the end position. So let's just copy and paste it. Now we need end x, and yeah, you guessed, and y. And the next thing that we need to specify is custom color that we created previously. So yeah, I think that this is good now, that we can basically test it out. So let's go to our Unreal Engine. Let's compile our code. And let's wait a little bit. So let's see if everything is all right. Okay. Let's click I, and our engine has crashed. Okay, and after some tests, I find what we did wrong. So basically, we are checking if for each loop we are checking if this y lines is greater than I, and that is not the index that we specified before, and that is index of j. So just delete it and just change it for a j, and that will fix our problem. So let's test it out now. Go to your Unreal Engine and click on this compile button. We need to compile our code, and let's see if there's any errors. There is not. And if we just click our Y button, you will see this right here. So our lines are not in the place that we want, and that is a thing that I mentioned that it will be mystery until now. So we need basically to get a top left corner, basically coordinates of our top left corner of our grid. And let me just check in my other project. So basically we need to get the top left corner of our grid border, basically our grid inventory, and we need to get those coordinates that we are going later to add with our position A and position B. So we need to, it will be a type of vector 2D. I will name it top left corner equals grid border, because we need a grid border. We need to get basically the coordinates of top left corner of our grid border, and then we need this minus greater sign. We need a function that is called get cached geometry, and then dot get local positioned coordinates. And we need basically to specify the coordinates, and that will be 0.0f and 0.0f. So basically the top left corner of our grid border will be at position of 0.0 and 0.0. Okay, and now we need those position A and position B to add with top left corner. And you will see that our lines will get in place. So let's save it, then go to our Unreal Engine and compile our code. Okay, and let's see what we did. And yeah, as you see, our lines are in place, but the one problem that we have is that our basically our horizontal lines are not getting shown by, but yeah, let's just go straight into code editor and fix the bug. Okay, after a little bit of looking into my code, I finally found what was wrong. And the mistake that I have made is here in create line segments function. Basically, when let's for example say this line right here, we are calculating this, we are multiplying the index by tile size, and that in that situation our x that is storing that values each time when we loop will hold the start position and the end position of our x lines. And in this situation, like here, we need to store the start position of y lines and the end position in y lines in the y lines array, but we are actually storing it into x lines, and yeah, that was actually a mistake that I have made. So just fix that like I did. And the next thing that we are going to do is actually test it out, and after that I'm going to explain what we did here. Okay, so let's just go to our Unreal Engine, let's compile our code, and let's see what we did. So let's play and let's click our input action button, and yeah, you will see that we have this spatial inventory look right here, and we yet don't have any logic for that inventory. So now let's test out with other values like number of columns, tile size, and number of rows. So go to third person blueprints, third person folder, third person character blueprint actually. Let's click on it, and let's say 5 columns and 7 rows. Okay, and okay, tile size for now will be 50, and let's test it out. And if I click, you will see that our grid inventory changed. That's really cool, and yeah, we finally did it. So now the last thing that I want to test it out is basically the changing value of our tile size, and let's set it to 25. Let's compile it and test it, and you will see that our inventory grid is now smaller, and yeah, actually we did it. So now let's go to our code editor, and I want to explain you basically this code block right here. So let me just explain you what we did here. So we are declaring integer 32 type of variable that is named k, and we are initializing it to a 0. The next step, we are doing for loop actually, and we are checking if we are actually looping for every time how big our x-line array is. So basically we are getting the size of that x-line array, and so later when we are getting the coordinates, it really depends how big the array is, because we just cannot get some elements that are not in the array. And basically we are looping on how much elements do we have in that array, and that's why we are using this .num to see the size of our x lines array. The next thing that we are doing, we are using another, or basically we are creating another for loop, because sometimes the number of rows that we specified can be different. and if we just basically set here I, it will just get the coordinates that are at the same index at the y lines. And for example, try to imagine if we have more elements here in the x lines than here in the y lines. It will just be something like 0, 0, and it will not draw lines correctly. And that is the reason why we are looping here. You can maybe just use a while loop, but never mind, I'm now using this for loop, and it will just implement, or not implement, but increment or getting the I value, which is incrementing for every loop, and it will just store that I into k loop that we are just going to specify here, and based on that we will get all the indexes that we need for our y lines, and basically that's it. So I suggest you to just try here changing into y, and if you don't understand it properly, try something that is confusing you, and see what will happen. Okay, so the very last thing that I want to do, and I promise this is the last thing for this part, is to basically increase the thickness of our inventory, because by that I think that our inventory will look same as Raid's inventory that is made with blueprints. So here in the drawLine function, just we need to type false, and then we need, as the last parameter, we need to fill it with the float value of a thickness. So just save it, and now go to your Unreal Engine. We will compile it. Okay, and let's see what we did. So okay, let's just increase the tile size. It will be 50, and okay, this okay, and yeah, as you see, our lines will be thicker now. So we have got to the end of this part. Finally, we did all the work that we needed for this part to be done, and yeah, I'm proud of you guys. So thank you for watching. Don't forget to subscribe, to leave a like, and most important thing that you need to do and that I want from you is, if anything is unclear, feel free to ask in the comments below, and our team is just going to help you.